So let's start writing the code for merge sort, right? So the first thing, I already have a public static void main written, just a boilerplate code where I have taken an array which is not a sorted array, and I'm going to call a function basically sort, which I'm going to sort the array, right? So let's start writing a sort. So I'm going to have here integer. So it needs to return an integer array, and it needs to return the sorted array. So I'm basically having a return type of an array, integer array. Now, what are the parameters I need? Obviously, it needs to know what array it has to sort, right? What is the starting index and what is the ending index I need to sort the array, right? I mean, for the first time, obviously, it's going to be from 0 to the last index of the array, but you're going to do a recursive call. So obviously, you need to know what is the sub problem which you're trying to sort here, right? So that's going to be given by start and end. For the first time, if you can see here, let me just, uncomment this. It's going to be start will be 0 and the end index would be the last index. Last index can be simply be taken by a.len, which is going to be the length of the array minus 1, right? I hope you get this. Now let's try to write the code. If your start is less than end, which we had seen in the video. If you have not seen that part, please make sure that you first look at the explanation of merge sort and then come here so that you will understand the code very well. So if your start is less than end, meaning that if there is more than one element present in your sub problem, you have to do the step of division. To divide, we need to find out the middle element, correct? Now, when I was teaching you the logic, I simply said use start plus end divide by 2, right? This is what we did. And if you do that, there's no harm as long as the elements which you're trying to work with, I mean the values you're trying to work with, are not going to get into an overflow. If you want to avoid overflow, if you remember from the binary search series, we have to use start plus end minus start divide by 2. If you are not sure why these two are equivalent, just check out my binary search series in which I've actually explained why these two are equivalent and why this one will never run into an overflow. Okay, now having calculated the mid, I need to basically do the recursive calls. Now I'm going to pass the array A. The first subproblem starts with start and ends at mid. The second subproblem is going to start from mid plus 1, right? And it's going to end at the end index, right? This is going to do the job of what? Sorting or dividing the array into smaller subproblems, right? Whenever you finish this whenever these two function calls are done, right? When you come at line number 17, what actually is happening is now you have basically, by the time you come at line number 17, you have two subproblems, right? Basically, you have two subproblems. One subproblem which is starting from start to mid, and another subproblem which is starting from mid plus 1 to end, which is already sorted. Now we have to combine them into one big, subproblem from start to end, right? So I'm going to need one more function, merge, right? Which is will be taking A as basically the array, start, the mid, and end, right? I will need these three basically variables. I mean, I'll need these three variables, start, mid, and end, so that I can make a distinction between the two subproblems, right? So I've not defined it. Let me just quickly define it here. So I'm going to have void. I do not need to return anything. This will be my integer array, right? It's going to be int start, int mid, right? And we have int end. So yes, I messed up some comma here, right? And let's come back. This is what we need, right? And after this, like suppose after this job is done, right? What we have to do is simply return the array, right? So that's what we are going to do. Like sometimes if you are not, like if you have a sub problem which has only one element, then this if condition will never be true. Then you simply need to return the array because there is no changes, right? Because if an array, if it's a sub array, okay, whose length is 1, there's nothing to sort in that. That particular sub array of length 1 is already sorted, so I'm simply returning A. If it is not, then we are making sure to divide it, solving that sub problems and then returning the value A. Okay, so this will be my sort function, right? Now what is remaining? To check the merge function. Now before we write the code for merge function, we need to discuss one small thing and then we are ready to write the merge function. So let's start. Suppose for a merge function, what you have is, let's talk about this array, right? What we said in the merge function is nothing but your combination step where you're basically combining two sorted subarrays into one big subarray which is already sorted, right? Now let's be very attentive because this is something which most of the students get confused in, right? So let's say I have a sorted half. Let's take the same example which we actually use for discussion. If you see here, we had this part, right? Let's talk about this two sub-arrays, right? What is it? 27 and 38 is already sorted, and 3 and 43 is already sorted. So let's write that 27 and 38. Okay, so 27, okay, and 38, and we had 3 and 43. Sorry, second, this is 3. This is 3 and 43. Okay, these are your indices 0, 1, 2, 3, 4, 5, and this is 6. Let me use the same color just to be consistent. So I'm going to use blue color. Okay, now tell me what will be the elements present here. These will be the elements normally which are there in the array, which will be your 9, 82 and 10, because this is not this, I mean, there is no sorting done for the remaining array, which is from elements from index number 4 to index number 6. I hope you get that, right? Now we are basically having our start is pointing to index 0, right? And our mid, and our end is actually pointing to basically this. Where is your mid basically pointing to? Mid is actually pointing to this part, right? Because from 0 to 3, you'll have 3 divided by 2, which is nothing but 1. So start to mid, 27 and 38, and 3 and 43. Right now this is sorted because we are at this step. We are basically at the step where we have to do combination, right? Here we have 0 to 1 is already sorted. This is already sorted. Now we have to combine them into one big sorted array. Correct? Please remember, everything needs to be done in the A array. Your input array only. Correct? Now your job is to make sure to sort this, and you need to have your A array should be looking like this. Finally, after your combination is done, you should basically have your 27, 38 and 43 at indexes 0, 1, 2 and 3. Correct? Now tell me, when we discussed about, when you had two different sorted arrays and you had to combine them into one, what we did was, as a part of output, we actually created a new array whose size was equal to the size of these two sorted arrays. Correct? But here we basically, instead of having two different sorted arrays, what you are having is two sub arrays. The difference is you are having two sub arrays. Now because of this, you will have to use some extra space. Okay, why? See, finally you want your output is what? To merge the array, right? Merge the two sorted sub arrays into one big sorted sub array. And what is your one big sorted sub array? This one big sorted sub array, which is going from 0 to 3, needs to be stored in which array? It needs to be stored in the array A. Correct? So let me write here A. Okay, so I'll have 0, 1, okay, 2 and 3. Right now at 4 is basically 9, 82 is 5, and this 6, we are not really bothered about this right now, right? We are supposed to till here this needs to be sorted. Okay, so if I have to do this, all right, I will have to take two temporary arrays. Let's see, I'm going to create a temporary array called as L, which will have the elements which belong to the first sorted subarray, which is 27 and 38. So I'm going to write here simply 27, 38. And the second array, let me call it as R. The reason I'm calling it as R is because this is the right hand side and this is the left hand side. That's all. You can have any other nomenclature. So this is going to have 3 and 43, right? They are going to have their own indexes 0, 1, 0, 1. Now, one question people will have is, how do I know the size of the array, right? Because if you have to declare an array in any language, you need to know the length of the array which you're trying to declare. Tell me, if you know the starting and the ending point of a subarray, can you find out the length of the array? Yes, absolutely. We did look at that concept, right? Let's say the length of this L array is n1. Can I find n1 is equal to mid minus start plus 1? Yes, if I say mid is 1, 1 minus 0 plus 1 is going to give me 2. So I need to create an array of size 2. What about n2? n2 will be the size of an array R, right? What can I say? This will be the ending part is what is given by the index end, right? So I'll have end minus, what is the starting point of this subarray? What is the starting point? If this is mid plus 1. Agreed? If this is end, this is mid, this is mid plus 1. So what I'm going to put in the same formula, end minus mid plus 1, right? Because we said the ending index minus the starting index plus 1, right? So if I solve this, tell me, I would have end minus mid minus 1 plus 1. minus 1 and plus 1 are going to cancel out each other. So what do we get the formula as? For n2, the formula would be end minus mid. What is the end index? 3. What is the mid index? It is 1. 3 minus 1 is 2. So we also get a size of R as what? Which is basically n2 is nothing but 2. So can we use this basically small formulas, right, to find out the length of our subarrays, those two subarrays which are sorted? Yes. Once you know the length of the subarrays, can you now create this temporary arrays L and R? And now we just have to copy the values of this left half into the L array and copy the values of the right half into the right array. Yes, we can do that. Yes. Now we are going to apply. Now tell me, we have actually converted our problem. What was the problem? That we had two sorted subarrays, right? And we had to merge them into one big subarray which is sorted. Now we converted this problem into the known problem which we already know, that if you have two sorted arrays, we have to combine them into one array, isn't it? Because now we have two arrays here. Okay, so now you know, I hope everybody remembers how to solve this problem. Let's take a different color for the indices. So this is your I, this is your J. Okay, I can take another variable K, okay, which is going to, run over A, right? Right now, just to show you, okay, just to show you, your actually values will be 27, 38, 3, 43, right? They're going to still be here, right? Now they are going to just get overridden when you're going to solve the problem. Okay, but it doesn't matter if it gets overridden because you've already have the value stored in your left and the right array, right? Now between I and J, which is the smallest value? 3 is the smallest value. So what we need to do? We need to say A of K should get the value what? A of K should get us the value. Let me write here with the black thing. So A of 0 or A of K should get the value of 3. K should become K plus plus. J should also become J plus plus. Correct? Now between 27 and 43, who's the smallest? 27 is the smallest. This should get a value of 27. Let's try to. This should get a value of 27, right? And K should become increase and I should increment. Okay, now between 38 and 43, who's smallest? 38 is smallest, so I should put a value 38 here. K needs to get incremented, I has to get incremented, right? Now tell me, I has already reached what? Index number n1. That means all the elements which are present in the left half of the array have been, stored into our output array. What is now left? If there are any elements left in the right side, we have to just copy them as it is in the same order in our output array. What will we do? Simply it's 43 here, so we're going to just add 43 here, increase the value of K. J needs to be incremented. Now J also is being equal to n2. That means we have also copied all the elements which are present in the right half into our output array. So you see, after doing this step, your A array, which is basically your input array, right, is having now the sorted array, right? Can you see this? Let me just erase this part so it becomes a little clean. So now you can see we actually started with this array, right, where we had 0 to 3, which was basically a subproblem, two subproblems which were sorted. We have finally solved this answer to the subproblem from 0 to 3, where 0 to 3, this entire subproblem now has been sorted. In other words, from start to end has been completely sorted. We solved this problem by taking an extra space to do this. Tell me, we will need this extra space of left and right for every subproblem. Wherever in this question, wherever you're doing this job of combining, right, wherever you are combining two subproblems, you would need extra space, right? Extra space because you're creating two different arrays, right, other than your input array, right? So you're creating these two different arrays and you're making some extra space for what? For the job of processing, for the job of combining the two sorted subarrays into one sorted subarray, right? Am I right? If you're doing this, what is the extra space you're taking? The extra space would be given as something like this. I could say the extra space. What is the extra space you're using here? The extra space you're using is nothing but O of n1 plus n2. Right? What is the size required for n1 and n2? Can I say in the worst case, the extra space I'm taking is O of n is basically the linear extra space I'm taking, because for every subproblem, I'm going to construct this n1 and n2. Right? Right, so you're going to construct this all the time. Once that subproblem is over, obviously that memory is also been, free. Again, when you solving another, when you call that merge call again, you're again going to create two subarrays of sizes n1 and n2. Again, use it for the job of merging. And again, you have to keep on repeating this whenever the merge call has been called. That means the extra space which your merge sort is going to take is going to be how much? O of n extra spaces needed. right? With having said that, now let's try to put this understanding into our code. Okay, so in our merge call, right, we have this start, mid and end, right? So let's say we have to do what? First thing is we have to create those arrays L, right? And we have to create the second array, which is basically integer R, right? So we have to create this array. Let me say new int, okay, let me say n1, okay, and here it will be equal to new int, and let me say this is n2, right? So I need to now define what n1 and n2 means, right? So let's do here int n1. What will n1 be? This is basically the size of the first sub array. That will be nothing but your mid minus start. Agreed? And your int n2 is nothing but will be, and in mid minus start plus 1, right? We have to also add plus 1. Here this will be basically end minus mid, right? I'm just adding end minus mid because we just saw in the on the whiteboard that plus 1 and minus 1 gets cancelled. Okay, so I have n1 and n2. What next needs to be done? I have to now fill up the values of L and R array. How will I do? Simply write a for loop here. For int I equal to 0, I less than n1, I plus plus. What you need to do? L of I will be given the value of A of start plus I. Do you understand this? Why start plus I? Because understand that your start can be anywhere, right? Like for example, when you're trying to combine, let's say these two, okay? Tell me your start is here, right? So this is index number 0. But not necessarily always your start index is going to be 0. Think about this part where you're combining this subarray and this subarray, which is only of length 1, right? Can you see this? So when you say the start is 4, it's not basically what? 0. So you will be actually creating like this. Let me put here 9 and 82. So let's say we will have 9 and 82, which is at index 4, 5, right? And the other part is index number 6, you actually have 10. You will be creating L here, right? Where you want to copy 4 and 5 here. L index starts from 0 and 1, right? Because every index, new array index always starts with 0. Now what you want is, you want this is given by start. You want 9 to be where? Here. So in other words, your L of 0 should basically have a value of what? A of start. L of 1 should have basically a value of start plus 1. Yes. So tell me start is nothing but 4, right? This is what? 4 plus 1, which is equal to 5. Can I write this in terms of formula? L of I is nothing but A of start plus I. And let me say I is starting with 0. So here 4 plus 0 is going to give you basically 4. So A of 4 will be filled in L of 0. Start plus 1 means 4 plus 1 is 5. So A of 5 will be filled here at L of 1. Do you understand? Same logic you would require for R. In your R, your basically right hand part starts with mid plus 1. That means what you're going to have, instead of start, now you're going to have mid plus 1 plus I for your R of I. Okay, I hope that is clear. So I'm going to just simply have start plus I. Same thing I will have to do for R, right? So I just need to update this with N2. This will be mid plus 1, right? So I have mid plus 1 and this is going to be R, right? Why mid plus 1? Because the second subarray actually starts from mid plus 1. So what I have done, I have just copied the elements into my left and right half. Now this is basically the step of merging. So let me have indices here. Int I equal to 0. J is nothing but it is going to point to the first element of my right hand side array. Okay. And K is going to point to start. Why start? Because K is nothing but what? K is actually the index, which is, let me just show it to you here. Yes, when you were actually solving the question, K index was pointing to where your start is pointing, right? From start to end, we want to what? This is where your output array is, right? We want to merge them and put it into our output array, which is basically the input array, the AL array, and which is starting from index number start to end. So that's why K is going to start from start. All right, now simple. We're going to write simple this. If I is less than N1 and J has to be less than N2. What are you going to do? If, right? If basically L of I is less than or equal to R of J, right? If this is the case, what you have to do is we need to put the value of Li in our input array, I mean basically your output array. So here you're going to have a of k is going to have the value of L of I. Because we have put the value of L of I inside the inside our merged array, we are going to increment I plus plus. If this is not the case, so obviously the element which is present in the right hand side is the smallest one. So a of k will basically have here r of j, and then we're going to do j plus plus. Correct? Make sure after if and else we are incrementing the value of k as well. Otherwise, you will keep on writing to the same location, right? After this is done, right? After this is done, what needs to be done? We have to make sure that all the elements which are present in left and right are already present in our, output array, right? So what you're going to do, how can you make sure of that? If I is still less than n1, that means there are still some elements which are present in left of the array which are not added to the output. So how can you do that? Simply a of k will be given the value of L of I. Please make sure that you increment I and also increment k. Same thing needs to be replicated for your second array, right? Which is your this. So here I'm going to have r of j, right? Make sure j is incremented and k is incremented, right? I hope you understand that only one of this while loop is going to run, right? Like in the example which we were seeing, like what happened was that the left part was already added to the array. There were some elements which were present from the right hand side which were not added, right? If you look at this 43 I think was added at the very end because we had finished. See, J stopped at index number 1 and I stopped at index number n1, right? So all the elements in the I were already added, but the elements which are present in R were not completely added. So we made sure that how do you know that those elements were not added? Because the value that index J, okay, if J value was less than n2 after this, while loop is completed, that means that elements from that array were not, not all elements of that array were added to the your main array, right? So that's what I've done. While j is less than n2, a of k is equal to r of j plus plus, and obviously needs to increment k plus plus as well, right? So, and this basically completes your entire merging operation. Okay, I hope this helps. And now what we're going to do is we've already called here. Let's now simply run a public static void main, right? It's just a boilerplate code. I've written an array which is not sorted, right? I'm creating an object, calling the sorting function, and I've just made it a point to, after the sorting has been done, I just wanted to print the elements, right? If you see the elements were 12, 11, 13, 5, and 6, I wanted to print it in ascending order. It's giving me the correct output 5, 6, 11, 12, and 13. Okay, I hope this makes sense. You can find this code in the GitHub link, which I will be linking in the description. Okay, so if this is understood, last bit of the video would be basically to understand the time complexity of merge sort. Time complexity is very easy, so very easy peasy. So if you want to solve the entire problem of sorting, okay, using the merge sort algorithm, how many elements you have? N elements are present in the array. Let's say the time complexity required or the time required to solve your entire problem of n size is T of n. Okay. What you do, you actually divide the problem into two parts. So I'm going to say 2n by 2 plus, let's say you've solved, this is nothing but T of n by 2 is nothing but the time required to solve a subproblem, okay, of size n by 2. In other words, how much of time do I require to solve the subproblem of size n by 2? And because I'm dividing my n into 2n by 2 parts, right, what is this? I'm going to have twice of n by 2, okay? But just by dividing this, is your answer complete? No, this is the step of division. After that, we have to have some time required for merging, what we can say combining, and that is how much it is. It is going to be O of n, right? Because it's going to be O of n by 2 plus n by 2, which is going to be O of n, right? Now, if you solve this question, if you solve this recurrence relation using Master's theorem, it comes up to O of n log n. So the time complexity for merge sort is O of n log n, both for your best case, worst case, and average case, right? So O of n log n is your time complexity for merge sort. Now, if you look at this, if you have studied other algorithms, you would know that in the best case, like for example, if it's a insertion sort, in best case, the best case for that insertion sort is when the array is already sorted, and then you have the time complexity as O of n. But if the array is sorted in reverse order, the time complexity, the worst case, is O of n square. That means it's, kind of oscillates between O of n to O of n square. But that's not the case with merge sort. Please understand. The merge sort algorithm is not that intelligent enough to understand whether the array is already sorted or not sorted. Even if you give merge sort a completely sorted array, it is still going to keep on dividing. It's still going to do all the process and, finally give you the same array, which is 2, 3, 5, 6 and 7. So in terms of asymptotic time complexity, in terms of asymptotic notations, the time complexity required for merge sort, whether it's a sorted array or not sorted or partially sorted, is going to always remain constant, which is O of n log n. Okay, I hope this helps. The last part is space complexity. Obviously, you're going to, when you define space complexity, it is usually the amount of time space you require for the input and also the amount of space you require, the extra space you require for processing. Here, the extra space required for processing is O of n, because you create that left and right array, and plus you would require space to store your input array O of n, which actually comes down to O of n because you kind of neglect the constants when it comes to asymptotic notations. So space complexity is O of n, both for best, worst case and average case, and the time complexity is also O of n log n. I hope this helps.